We all know about sound, but what does it look like? In this video, we're going to see it in 1, 2, and 3 dimensions. And we'll discover that sound can move objects, strings, glasses, tuning forks, and yes, even you. Do we have a magic frequency? We'll find out. But first, let's start with 2 dimensions. A vibrating metal plate creates these mesmerizing patterns. As we change the frequency, the pattern changes. Very cool. But what's going on here? Let's look at just 1 dimension, viewing the plate sideways. The particles are bouncing up and down, making interesting patterns, kind of like a guitar string. To investigate, let's use a vibrating coil connected on the left to a spring, and the right side of the spring is fixed. We're going to drive the vibrating coil with a frequency generator for accurate control. Okay, let's get started. The spring is responding to the vibrating coil by moving up and down like a skipping rope. If we time it right, we can get a pretty big peak in the center. But this is not the only shape we can make. If we speed up the vibrations, we can make this shape. We're going to need some vocabulary to talk about this. The shape that you see here is called a sine wave, smooth up and down curve. A lot of things have this shape, like electricity and light. If we draw a line through the middle of the sine wave, the points that intersect are called nodes. The distance between the end nodes is 1 full cycle. If it takes 1 second to travel from the far left to the far right node, we say this sine wave has a frequency of 1 cycle per second, or 1 hertz, abbreviated HZ. Our spring currently has a frequency of 27 Hz, as you can see here on the dial of the frequency generator. We can increase the frequency, which changes the shape once again. Now we have 3 peaks. If we crank up the frequency even further, we get 4 peaks. As the sine wave oscillates between max and min positions, you can see that the nodes don't move. Looks like a lot like our metal plate that we saw earlier. The metal plate is oscillating just like the string. At the max and min spots, the plate causes the particles to jump up and down, but they don't move at the nodes. And when we look at the full plate, this effect is occurring in 2 dimensions, with the increased complexity creating the cool patterns. Changing the frequency changes up the pattern. Notice that it's only particular frequencies that lock in patterns. We'll explain that a little later. Hey, want to see 3D waves? We'll save that for the end. Now let's explore how sound works. Sound needs 3 things: a source, like a bell, a receiver, usually an ear, and some way of traveling between the source and the receiver, called a medium like air or water. Hitting the bell sends sonic energy in all directions. The air molecules vibrate in response. This wave of energy may reach an ear that can detect it. That's sound. This doesn't work in outer space. There's no air, so no medium for the sound energy, and no sound. Let's go to the forest and a falling tree. Just like the metal plate, air molecules vibrate in response to the sonic energy released by the falling tree. This generates a wave rippling through the forest. But once it comes across an ear, it becomes sound. If the vibrating air molecules reach a creature without an external ear, there is no sound. And not all ears hear the same sounds. We can hear sound from 20 to 20,000 Hz. Or 20 kilohertz, since kilo means 1000. This means that if somebody blows a whistle at 40 kilohertz, we would not hear it. But a dog would. Dogs can hear sounds from 15 to 50 kilohertz. And dolphins, with their intricate click and whistle language, have an astounding range from 150 hertz to 150 kilohertz. Sounds can look different even at the same frequency. A flute's sound shape is very similar to the pure sine wave, but the sound from a trumpet looks very different. Why is that? The trumpeter's vibrating lips generate sine waves. The main tone you hear is the fundamental frequency. but the complex trumpet tubing creates different resonances or echoes of the fundamental frequency. These are also sine waves called harmonics. When the sine waves combine, they create this modified shape. This shape gives the trumpet its unique sound flavor. Change the tubing and the sound has a different flavor. Other instruments use other materials and configurations, producing their own unique sound flavors. And what does our speech look like? It's a mess. Something like this. It's more interesting if we look at the output from a spectrum analyzer. It shows individual frequencies rather than sound levels. Each bar shows you how loud each frequency is in the sound. So if we look at the tuning fork, there's just one frequency, the fundamental. If we look at a flute, it has primarily a fundamental, but a few other little ones. The trumpet, on the other hand, has a whole host of frequencies. Many things around us respond to at least one special frequency, many in the audible range. Like the spring we saw earlier, forming special shapes when stimulated with the right frequency. This is called resonance. How does it work? Let's take a closer and slower look at a wine glass. We connect our signal generator to a speaker pointing to our glass. Nothing happens. Let's slowly increase the frequency. The sonic energy ripples through the glass, bouncing back and dissipating. But when we reach the resonant frequency for the glass, the new burst of energy matches exactly with the bounce back, reinforcing the motion. And like a swing, that increases the oscillations until the energy of the vibrations exceeds the elasticity of the glass. Do we have a magic resonant frequency? Our chest cavity resonates from 50 to 100 Hz. This is why you can feel bass in your chest at concerts. Skull bone resonance is roughly 20 to 30 Hz. Brain tissue resonance is harder to measure. Ocular resonance is 30 to 90 Hz, depending on direction. So if you're exposed to these vibrations, you'll have blurred vision. There's a few more, but you get the idea. There's no magic single human frequency. The human body is not a rigid object with one resonance like the mechanical examples we've seen. Our bodies are a stack of bones, fluids, organs, cavities, and tissues. Resonance depends on mass distribution, posture, muscle tension, hydration, and even breathing. It makes no more sense to say humans have a single frequency than to say a guitar has one note. Now for the 3D sound. We're going to need a big speaker, our frequency generator, and a container. We'll add some colored water to our medium to see the waves better. Let's see what happens as we ramp up the frequency. Just like the metal plate, the patterns change depending on the sound. And just like the string, the patterns depend on distance, in this case, length and width of the container. If these are even multiples of the frequency emitted, a stable pattern will form. Cool. Let's try a circular container. Oh, the whole thing is moving! The sonic energy is oscillating the bottom edge of the cup, reducing friction, and it's sliding in the direction of surface tilt. That was unexpected. Sound is just one form of energy. Explore 9 other types of energy in this video. Click here.